This is Module 9, Lesson 2. You can find this on page 280 in your math book. This lesson is called Use Addition and Subtraction Equations to Solve Problems. Again, you can find this on page 280. When solving an addition equation, you can model the equation on a balanced scale. For the equation to remain true, both sides must equal or, in the case of a balanced scale, be the same weight. If you remove something from one side, you must remove the same amount from the other side. So if we look at number 1, it shows us a picture of a scale and some weights on there. Weights are shown on the scale. Each square is 1 unit, but the value of the triangle x is unknown. Right over here, you can see a triangle, and there's a little x on it. He is unknown. The scale sides are balanced. Describe the weights on the left side of the scale and on the right side of the scale using both words and mathematical expressions. So on the left side, there are 9. On the right side, let me write right here for us. It says 4 here, but if we actually look in our book, there are 3. So I'm going to go ahead and mark one of these out, and I'm going to deal with the amount that you have in your book. So they kind of screwed up on the online book. So on the right side, there are 3. And 1 unknown, because we do not know that triangle. So let's see, mathematical expressions. We're going down to B. What equation represents the weight shown on the scale? So on this side right here, there are 9. So we're going to equal 9. On this side, we're going to have x plus 3 because we have an x and 3 more. And I know it's going to have to equal 9. How could you remove weights, making sure that the scale is still balanced, and use that value to find x? So if I remove 3 from both sides, the scale will remain balanced. And x will be alone on one side. Okay, I'm going to go to my next slide, and that's going to be D and E. So on page 280, you can see all this on one page, but because how I had to put it on the Jamboard, it's not going to be all on one page. D, as if you're removing weights from both sides of the scale, cross out the same number of weights on both sides of the scale using both sides of the scale until x is by itself. So I'm going to go back over so I can do that cross out. I'm going to change my color. So I'm going to cross 3 out. I have 1, 2, 3, 1, 2, 3. So all of those are gone. And so on this side, I have 1, 2, 3, 4, 5, 6 left. So it must weigh 6 units because there are 6 left when I crossed out the weights. Okay, now I am not going to expect you to draw a scale and do that on every single problem. So on part E, I'm going to show you what I expect you to do when you're solving this. So our equation we wrote back here on part B is 9 equals x plus 3. Or we could write it as x plus 3 equals 9. So I have x plus 3 equals 9. And so basically what they did, we took 3 away from each side. So I'm going to show you the mathematical way of doing that. So the opposite of addition is subtraction. So I'm going to subtract 3 from this side. Whatever I do on this side, I'm going to do on this side. So 9 minus 3 is 6. So that's how they got 6 for an answer right here. And yeah. So that's what you do. Whatever side the number and variable are on, that's the one you're taking away. Since I was adding 3 here and then I subtracted 3, I crossed this out because they canceled out and they made 0. If you don't quite understand, that's okay. I'm going to be doing a lot more practice with this. So let's head on to the next slide. You guys are on page 281 at the top. A plant is 6 inches tall, right here. In 2 weeks, it grew to 14 inches tall. How many inches did the plant grow? So the plant starts at 6 inches and the plant grows to 14 inches. What do we need to find out? How many inches the plant grew in 2 weeks? So we're going to type that out. Just like that. Then on C, you can represent how many inches the plant grew in 2 weeks with the variable x. How can you describe the relationship between the unknown amount x and the height of the plant at the start? So let's look into that part. Let me get my text box here. So we know when it starts at 6 inches plus the amount the plant grew, which is x right here, and that equals 14. I know it's going to equal 14 because 6 plus x is going to equal 14 because that's what it grew into. I'm talking with my hands like you can see that, but you can't see that. So we went from a 6-inch all the way up to 14. So 6 plus something equals 14. And that's what we're going to try to figure out on part D here. So on part D, it says write an equation you can solve in order to answer the problem. So I started at 6. And it doesn't matter if you put 6 here or here. I'm going to end up putting 6 here. They told us our variable we're going to use is x. So x plus 6, our total that's going to grow to is 14. We are going to skip this e part here because that is just going to confuse you. And we are actually going to solve right down here on F. So I'm going to rewrite my equation I got from up here. So I have x plus 6 equals 14. The opposite of adding 6 is subtracting 6, so I'm going to subtract 6 from both sides. So 14 minus 6 is 8, so x equals 8. G, check your answer by substituting the value for x into the equation. And we already did that right there, so our answer is correct. Hey, well, as I go to the next slide, you guys are going to be going to page 282, and we have some vocabulary words on this page, and it's the vocabulary words of what we've been doing. So instead of using a scale or algebra tiles, I kind of introduced it to you on the last pages because this is what we're going to do. You're not going to be drawing a scale or using those algebra tiles. I even crossed out those algebra tiles for you so you wouldn't get confused on how to do this. So You can subtract the same amount from both sides of an equation, and the two sides will remain equal, and that's what I showed you on our two problems before. This is known as the subtraction property of equality because we are subtracting. Let's look at number 3. Sarah has $8.50 in her pocket. She earned M, so that's our variable there. Our variable right here is M, dollars babysitting, and now she has $20.25. So this is what she had, and this is what she has total. So how much did she earn babysitting? What does M represent? It's the amount Sarah earned. And I'm going to put a text box on here so I can type that. Okay, now we're going to take that information that we got up in 3 and put it in B. So we have 850. So 850 plus M, or you could have M, I guess on this one they have the dollar signs there. If you needed to, you could put the M before the 850. And our total is 2025. So 2025. How much do you need to subtract from both sides of the equation to get an equation with only M on the left side? So this right here needs to be taken away. So since we're adding here, the opposite of adding is subtracting. So we're going to subtract 850 from each side. So we're writing 850 here. And then we're going to write subtract 850 here. From both sides, the isolate. Isolate means to get M by itself. So we're going to put 850 here. When we do that, 850 minus 850 is 0, so I'm going to cross that out. If I subtract 850 on that side, I'm going to subtract 850 on this side. The only thing left on this left-hand side now is M. 2025 minus 850 is 11.75. And I'm just going to carry that down into part E right here, into 11.75. So Sarah earned $11.75 for babysitting. Number 4. You can also add the same amount to both sides of an equation, and the two sides will remain equal. This is the addition property of equality. So this is the opposite of the subtraction property of equality. So if we look down here on part A, solve the equation x minus 7 equals 12. This 7 right here is on the same side as the x, but in this case, unlike our other ones, we're subtracting 7, so we have to add it to each side to make it cancel out. So here, we're going to add 7 to both sides. So plus 7. The opposite of subtracting 7 is adding 7, and that cancels out. Since we added 7 on this side, we have to add 7 on this side. The only thing left on the left-hand side is our variable, and 12 plus 7 is 19.